place one. So let's say you are traversing on the basis of I. So I is going from 0 to n minus 1. Okay. Then you are placing your I here. So this is my I. Now I want to find relative. I want to find where j and k is. So obviously j and k would be in this subarray. Correct. Are you able to understand? Yes. No.
Yes.
Okay. Cool. So for us, it becomes very easy that we already know I. Then we should find j and k from here to here. Correct. And hence we can use the two pointers. So instead of going into the medium level question, let's see how we can build up our understanding and solve this problem. Okay, so let's assume that instead of pair of three numbers, we are asked pair of only two numbers. Okay, and this array is given to us. Okay, so and we are asked that find where um, answer, I mean the sum of two numbers is 0. 0 equals sum. Okay. So if we want to find any combination in this entire array which sums up to 0, okay, then what we will do, we'll sort this array, then we'll start adding j and k, jth element and kth element. Okay. So nums of your, okay, I'll write down a little in a little detail. So say your j is equal to let's assume that 4 is not here, right? This 4 is not here. So j is sitting at 0 and k is sitting at n minus 1. Okay. And you will run this loop for while j is less than k. Okay. Because let's say your j also comes over here and k also comes over here. So you will compute this 0 twice and that will become a uh, wrong answer. Correct. And since we know that we want j not equal to k, we have to use this particular um, j less than k. Is it clear to you? Yes, no? No, no. I said not to sort if the positions are asked. Okay. In this case, they are not asking you the positions. They are asking you the numbers. Did you get it? They are not asking for the positions. They are asking for the numbers. So the answer is this one: nums of I, nums of j, nums of k. Instead of that, if they would have asked you कि j, I, j and k का position बताओ, then that would have been uh, a key to you that you need not solve it, or rather you should not solve it. Okay. Coming back to this example, so when we will have sum equals nums of j, nums of j plus nums of k. Okay. So initially we will add this minus 1 and 2. The sum of minus 1 and 2 is what? 1. But we are looking for 0. Correct? So 1 is not equal to 0. That means we have to move our j pointer. Okay? In order to maximize the sum. So what are the chances that you could find the bigger element after j? Because k cannot move on this side. K can move only on this side. So you can either choose to move j by one step, or you can choose to move k by minus 1. Okay. So in this case, I am choosing to move the j. So since I am looking for 0, but what I am getting as of now is 1. I need to move j. Okay, so j I have moved to next position. So j will come over here now. Okay. Now I will again do the addition. The addition will again yield same 1. 1 is not equal to 0. So I will again choose to move j.
Hello, sir. I think we have to move K because we have to decrease the count.
Yeah, so my bad, my bad. I'm so sorry. So yeah, we need to move
Move
j
K.
because we need to move towards a smaller answer.
Yes, yes.
Yes. So we need to move k by 1 position. Now this 1 and minus 1 will become 0. Okay. And hence this will be one of the pairs. Correct.
Right.
Again, since we have asked for multiple pairs, we will again move. So since we have found our answer as 0, right? We are free to move j now. So what will happen? This j will come next. And again, the sum of this 1 and this minus 1 will be 0, right? And hence we have found our second pair. So this is how for two sum we will draw the logic. Now when problem is for sum of three numbers, right? The problem says that sum of we have to identify three numbers I, j and k. So in such scenario, we will fix our I here, okay, and we'll check, and we'll basically have a logic of two sum over here. So this entire part will be two sum logic, just the thing which we tried just now. Okay. So in order to summarize this three sum problem, you should understand that this could be asked in a twisted language, but you have to see the pattern underneath, and the pattern would be you will be given an array, right, and you will be asked to check the combinations which are satisfying certain condition. Okay. Correct. So pointer inside a loop.
Can you go through the code once, Niranjan, if you have it handy at a high level?
Yeah. So I think I have it. Let me share it from different device. Although we cannot do this for every problem because there are a lot of patterns to be covered.
Instead of writing here, you can walk through the code itself, right? That will be give better understanding.
Yeah, but I mean, uh, when you see pictures, you tend to understand more, because understanding the code could be difficult for. I mean, there could be freshers or there could be people from other background, right? So let's do it. Let's try to mix and match.
Mm-hmm. It's very hard to imagine the things, right? Better if
Yeah.
we visualize it, it will be easy.
Unfortunately, I have to cover 14 patterns, and hence it becomes a little uh, difficult. So I hope you guys can see my screen.
Yes.
Yes, Niranjan.
So yeah, so this is the three sum problem.
Can you minimize your screen little bit? Just a bit too much.
Is it okay now?
Yeah, Niranjan. Niranjan, you just explain the logic only. The kind of
Should be fine.
work.
Right.
I think
So
that
see,
that works for 14 problems.
as discussed earlier, we'll first do the sorting. Okay. Then we'll have a for loop. For loop will run from 0 to n minus 2. Now why n minus 2? Because we have to find three combinations, right? So ideally we should stop at n minus 2. Even if we go up till n, then j and k would be out of bounds. So anyway, this code will throw some problem. So we can go up to n minus 2 as we want three numbers only. Then the first number that we will fix, the I that we will fix, we'll call it as minus a. Okay. Now, why minus a? Because at the end we want to add up these things. So you can have different approach over here. That's fine. As I told you in the depiction that j will start from I plus 1 and k will go up till length minus 1. And as long as j and k are not equal, we'll iterate, right? We'll find b, we'll find c, we'll sum up b and c over here. If the sum is found, the sum is found to be minus a, because anyway we want to uh, have 0, right? Instead of doing this complicated logic, you can also have a plus b plus c equals 0 or not. Okay, that's also correct approach, and no one would mind over it. So if the sum is found, then what you will do, you will create an element, because we have been asked to return the triplet. So we'll add a nums of I, that is A, B, and C in a linked list, and we'll add this linked list into your final answer. Okay. Understood? And as long
Yes,
as
yes.
your previous, as long as your previous numbers are same. So for example, j plus 1 is same as j. If that happens, then there is no point in again checking that. So for example, when we had two minus ones, right? And if we fix our one I to first minus one, then we anyway explore all the possibilities. So we need not go over the next minus one. Correct? I should not be fixed at next minus one. This will give us a slight performance advantage. Hence, this while loop is there. Understood? And again,
Yes, Anil, far enough, yeah.
yeah. And at the end, we will return the list. And these are some conditions for certain corner cases that you can anyway come up when you do the try run. Okay. So let's conclude the three sum, or a two pointer sort of problem. I'll share my screen again.
Niranjan, sorry to speak actually. One request. So we have a lot of problems. Okay, so rather than showing the code, you just show some problems where these patterns is applicable and how they're applicable. That's all.
Yes.
People can go through the code because you cannot go to the code and explain each and every line.
Right.
That's
I
really
also I'm also on the same page with you. But see, if there is need, then I can always show you the code. You guys can request me for that. That's fine. Because at the end, you guys need to get a value from this session. It's not for me. It's for you, right?
exactly, exactly. So you can just show two, three problems where they are applicable and how they are applicable. That's all. Then we can identify by ourselves.
Right, right. So next point is fast and slow pointers. So this pattern is a very interesting one. So I have noted down a simple, medium level problem, which is about linked list. So in this case, you will clearly be given a linked list. Okay. So if linked list is there and something like cycle, or find cycle in the pattern, or say essentially it deals with linked list only. Okay. So and they will ask you that at what time, at what point intersection happened, right? Or they will ask you to return true if cycle exists, right? So in all such scenarios, you have to use fast and slow pointers. Okay. So there are two major scenarios. One is they will give you a linked list. Second, if it is an easy level problem, they will ask you to tell if cycle exists or not, true in true and false. And in medium level problem, they will ask at what point cycle starts. Okay. You guys can write on chat so that I can understand if you are able to follow. Okay, someone had some questions about sliding window. We can take that up later after the session. Okay. Yeah. So typically, what happens? You will be given an array. Sorry, a linked list, like linked list of numbers, or it could be a linked list of characters. It doesn't matter. So say A is there, B is there, C is there, D is there, E is there. There is a single linked list, and E connects to C. So what you will do in this case, you will have a two pointer strategy. If so, I'm explaining you when you have to return true or false. Okay, this problem. Then we will see how we can convert the same understanding to a medium level problem. Okay, so you will have a fast pointer and you will have a slow pointer. Both will point here only. Okay. Now what happens is your slow pointer moves ahead by one step. So you will simply do slow pointer equal to slow dot next. Okay. And what happens to your fast pointer? It will move ahead by two steps. This is one step and this is like two steps. So your F will move for one step here and another step here. Okay. So far you are able to follow. And for the fast pointer, we'll do F equal to F dot next. And again we'll do F equal to F dot next. But in the second part, we have to make sure that F is not equal to null. Otherwise your code will break. Okay, so this is the corner case that we need to handle. Now, continuing on the fast and slow pointer, again your S will come one step ahead and your F will go one and two step ahead. Okay. Then how long we will continue this, right? There has to be a stopping condition. So now observe this very carefully. Your S is over here, which will move ahead by one step in the next iteration, and your F will move ahead by one step and two steps. Correct? So now your F and S, the fast pointer and slow pointer, both are pointing at D. So this will be your stopping position. This will only happen if this loop is there. Correct? If this loop was not there, then simply your fast pointer would have gone ahead somewhere here and it would have become null. Correct? So when you are asked a simple question where you have to return true or false, this would be sufficient. So your while loop will be like S not equal to F, or you can also choose a do while loop, because anyway at the beginning of the problem when S was here and F was here, you anyway had F equal to S. So using while loop directly would not give you the right result. So you can have a do while loop. So probably this is the only time when I use do while loop in my entire career. Otherwise, it was always for loop or while loop. Okay. Anyway, jokes apart. So the logic where you were sending the S equal to S dot next and your F equal to F dot next, then if F not equal to null, then again F equal to F dot next. This entire logic will come over here in the do while loop. Correct? So this is how your fast and slow pointer would work to detect the cycle. Okay, I'll again redraw the cycle. Now, if they ask you that tell me the position where cycle started. So we all agree that cycle started over here at C. Correct? Okay. There are certain questions. Let me take those quickly. So what does it say? Yeah, Shubham says it did cycle. Then Shubham already has code. That's great. Won't be handy for arrays. It's difficult for finding loops in data structure, especially linked list. Okay, there is some discussion going on in the group chat. Okay, what if my programming language doesn't have a while loop? What should I be doing? Use do not have a while loop. I'm not sure which programming language doesn't have a while loop. Maybe it could be Python or something which is not meant to be a object oriented language, or it doesn't follow the normal construct. But major languages do have while loop. And if you don't have a while loop, then still this is a pointer based solution, right? So maybe you can have a for true sort of loop, say for semicolon semicolon, something like that, or forever running loop, and you can check this condition while s not equal to f in a if statement. So in that case it will become like this. So if s is not equal to f, or rather s is equal to f, then break, right? It could be like this, and instead of this do loop, you could have a forever running loop. So for semicolon semicolon, something like this. So it's equally. I mean, it could just be fine in that case. Yeah. Okay, Python do not have while. Oh, good to know. Okay, so coming back to where you can find the start of the loop, right? So in that case, you will have another pointer. I'll name it as x. Okay. I will name it as x. So what happens with x is when you detect a cycle, when you are at this stage, right? You will use the slow pointer only. Okay. Now what you will do? You will move slow pointer with slow pointer by one step. Okay, and you will move your x by one step. Then again you will move your slow pointer by one step, and you will move your x by one step. Correct? And wherever these two pointers will meet, right, that will be your start of the cycle. So essentially, when the loop happens, you are equidistant from the start of the loop. So loop happened over here. So you were two steps away. So since this is a singly linked list, you were two steps away from the loop. And similarly, your start of the loop was two steps away from here, from the start. So यहाँ से equidistant and यहाँ से भी equidistant. Okay. Okay, I'll explain again. So just the way we had slow and fast pointer, I will have another pointer called x. Okay, x is also at a.